Good evening, everyone. My name is Gabby, and I'd like to welcome you back to another Tech Talk in our series sponsored by CaseBlink. Today, we have the pleasure of welcoming Dylan Compton and Ari Benkov to give us a brief talk about CI/CD security. So without further ado, I'd like to pass it on over to you, boys.
Thanks, Gabby, and good evening, everyone, and thank you so much for attending this talk sponsored by CaseBlink. My name is Dylan Compton.
And my name is Ari Benkov.
And today we are talking about the process known as continuous integration and continuous delivery deployment, or CI/CD for short. More specifically, we're taking a look at the security around CI/CD, what it is securing, why it is important, what happens when it goes neglected, and ways to implement it.
Let's begin by understanding what CI/CD is and how security fits into the picture. The Open Worldwide Application Security Project, or OWASP, says CI/CD refers to a set of largely automated processes used to build and deliver software. It is often portrayed as a pipeline consisting of a series of sequential, discrete steps. As the acronym implies, this pipeline can be split into two halves. The first, continuous integration, refers to a process of developers pushing their changes to a shared repository, often on a daily basis. The team's software will then automatically compile, package, and test the pushed code. This includes smaller tests, such as unit testing, which tests individual functions, and front-end or user interface tests. If no tests fail, it enters the second half, continuous deployment or continuous delivery. Both of these terms refer to the process in which code is transferred from the dev environment to production. Most of the time, this is where integration tests are enacted. Once these tests are passed, the code may be pushed to a small portion of the user base and given a waiting period, typically for 24 hours. So long as no problems arise, the code is then pushed to the full production level environment. The terms deployment and delivery are used interchangeably, but the National Institute of Standards and Technology differentiates the two. They characterize delivery as manually pushing code to production, whereas deployment automates everything, including this step. Throughout the entire CI/CD process, there are often steps where code is manually approved or sent back by one or multiple engineers. While the exact processes and software that the CI/CD pipeline utilizes changes from company to company, the ultimate goal to have repeatable, agile automation from commit to production remains constant.
To construct a fluid CI/CD pipeline takes a variety of people and technologies. For those in cybersecurity, this is extremely concerning. Having a variety of moving parts means having a variety of entry points for malicious code. OWASP uses the term attack surface to describe this concept. The wider a target is, the easier it is to hit. There are several components of the pipeline that can be targeted, including code repositories, automation servers, deployment procedures, and the very nodes the CI/CD process requires to run. Now, to get to these components, there exists a sort of menu of options hackers can choose from, a catalog of ways organizations may let their guard down. There may be insufficient detail in things like flow control mechanisms, identity and access management, pipeline-based access controls, and credential hygiene, or logging and visibility. Or there may be a lack of governance over things like third-party service usage or artifact integrity. These potential vulnerabilities are just the top of a long list. What makes the threat even more alarming than other cyber attacks is the proximity the pipeline has to critical information. At the end of the day, the pipeline leads straight to the production level environment. In other words, if certain checks are not in place, the CI/CD process can have a multitude of entry points, all of which lead to an all-encompassing access to an organization's code base. This is what makes CI/CD security so vital. In some cases, gaining access to certain elements of the pipeline can even compromise multiple organizations.
One such example of how vulnerabilities in a CI/CD pipeline can have far-reaching consequences is the SolarWinds Orion attack, which occurred in December of 2020. Orion is a third-party infrastructure monitoring platform, which offers many tools to supervise performance, traffic, and many other metrics for multiple organizations, including some United States government agencies. Lavi Lazarovitz, head of CyberArk Labs, described Orion as having its hooks in all facets of an enterprise, making it the perfect target for an adversary. It was the subject of a supply chain attack due to its ubiquity and therefore potential for high access to multiple targets, as well as its access to multiple sensitive areas of a given company's infrastructure. The attackers targeted Orion's CI/CD pipeline, consequently deploying malware to every user of Orion services through a Trojanized update. Because the principle of least privilege was not strictly enforced, the malware had high privileges upon deployment and was able to access credentials stored by Orion's database. These privileges allowed the malware to watch for code that could expose it and respond by stopping the execution of the security code or hiding itself from the automated security checks. Based on these events, it is evident that failing to secure even a single CI/CD pipeline can be a costly mistake, and in this case, one which granted malicious actors unobstructed access to upwards of 18,000 organizations. To prevent an attack like this, SolarWinds could have taken multiple precautions. The largest issue in this case was the privileged access that the hackers were given upon entry, which could have been prevented through strict least privilege protocols. There are also actions that could have mitigated the damage or slowed the process. Implementing credential theft protection policies, such as multi-factor authentication, could have been one such method.
Sometimes it is not the CI/CD pipeline itself that is breached, but a tool within the pipeline. CodeCov, a tool which monitors the testing coverage of a code base in the CI portion of the CI/CD pipeline, was the victim of a 4-month-long supply chain attack beginning in January of 2021, just a month after the SolarWinds case. Utilizing a flaw in the Docker image, the attackers were able to gain credentials which gave them the ability to alter the bash uploader script for CodeCov. They simply added a subtle line of code, one that rested on line 525 out of 1,800 plus lines, that sent all environment variables of every CodeCov customer to the hacker's server. Since the CI environment of an application needs access to sensitive credentials in order to fulfill its purpose of building and testing the source code, using production credentials in the CI environment can be a point of serious vulnerability. CodeCov occupies the CI environment of a given application. As a result, compromising CodeCov gave the attackers access to this information, allowing them to infiltrate all 23,000 of CodeCov's users and their private Git repositories. This includes companies such as Twilio, Confluent, HashiCorp, Rapid7, and more. A number of security tactics could have guarded against this attack. One strategy would have been to rotate credentials so that they could no longer be used to gain access. Another is to simply keep a watchful eye on as many facets as possible. This could mean monitoring logs to check for suspicious activity or scanning repositories and Docker images for sensitive information.
As we can see from these examples, it is of paramount importance to take steps to secure all stages of the CI/CD pipeline. There are several general guidelines a software engineer can follow when designing and building the pipeline. For example, several tools might be utilized in its configuration, including Travis CI, TeamCity, Jenkins, and Circle CI. It is imperative to take time and configure these tools properly, as leaving the default settings in place could lead to a security risk. At the same time, care should be taken when adjusting any settings. When configuring supply chain management tools, a few best practices to follow include staying away from auto-merge rules when using version control platforms such as GitHub, mandating manual review of pull requests to ensure malicious code is not automatically merged to production, making use of protected branches, and implementing multi-factor authentication as much as possible.
Identity and access management, or IAM for short, is also a crucial element in the security of the CI/CD pipeline. Failure to properly manage credentials and access can pose a serious security risk. CI/CD pipelines make use of key pieces of sensitive information called secrets, which might include passwords and API keys. While they are necessary for the proper function of the pipeline, they can also be exploited by attackers if not managed properly. An important best practice is to avoid hard coding or storing secrets in code repositories or config files for the pipeline, and instead use third-party tools such as HashiCorp Vault or AWS Secrets Manager. Another best practice is to use temporary credentials so that even if an attacker manages to obtain them, their access to sensitive data will be limited. Additionally, as mentioned in the second example, enforcing the principle of least privilege is a powerful method for adding security. The National Institute of Standards and Technology defines least privilege as the principle that a security architecture is designed so that each entity is granted the minimum system resources and authorizations that the entity needs to perform its function. In CI/CD, this principle should ideally be applied to secrets used at various stages in the pipeline for the purpose of accessing external resources, the access of any given step in the pipeline to other resources controlled by the pipeline, and finally, developer permissions. As a general rule, access should never be granted automatically, and any component of the pipeline should have only the bare minimum of permissions configured. Enforcing least privilege can also have the benefit of mitigating risk involved in integrating third-party plugins or other software, which, as we have previously established, can pose a security risk. Engineers should also take steps to mitigate the effects of attacks involving dependency chain abuse, wherein attackers take advantage of errors related to packages used as dependencies by the application. Some possible security measures include making sure dependency references are immutable when configuring the package manager, or performing version pinning to ensure a secure version of each dependency is used everywhere, and verifying system downloads via hashing.
The CI/CD pipeline is incredibly advantageous to the modern software development process, with its goals of automation and repeatability reflecting the needs of the engineers that designed it. However, the automation provided by continuous integration can be a double-edged sword which has the potential to deliver malicious code undetected. Protecting against attacks which either target the CI/CD pipeline itself or a tool within the supply chain can be instrumental in protecting sensitive information from falling into the wrong hands. Therefore, as we continue to develop and build secure applications, we should also take care not to neglect the security of this crucial pipeline. Here are our sources if you would like to continue to learn about this topic in the pursuit of security. Before we come to a close, are there any questions that we can answer?
All right, since there are no questions, we would like to extend a huge thank you to those who came out tonight. Thank you to Gabby Pasentino for hosting the event, and special thanks to CaseBlink for sponsoring this talk. You can learn more about their mission of productivity through automation at caseblink.com. Gabby, I'll hand it over back to you.
Hi, thank you so much for that informative talk, and thank you everyone for coming out tonight. We'll see you at the next one.